just a little flurry
Little
here and
flurry.
there.
We had some leaves that had some snow in there, but that was about it. We are going to do, if Chapter 18 has a heavy-duty portion, today is the heavy-duty portion. We're going to look at heart physiology today. We will likely finish up Chapter 18 come Tuesday, and that'll give us some time to start into Chapter 19, blood vessels. And like I mentioned on Tuesday, they're all related, so it does go very well hand in hand. So our topics today will include things like the intrinsic conduction system. We'll talk about the EKG. So we'll do some issues like that. We may actually get to some of the stuff that I had planned for Tuesday. I'm very comfortable moving that, that far into the topic. Exam 2 date, we had talked last class period. We're still looking at somewhere around February the 24th, and that's still covering just chapters 18 and 19. All right, so what we ended up in here with on Tuesday, the very last thing we did was blood flow through the heart, and I wanted to start you back by doing that today. Before we go there, did y'all have any questions on Tuesday's topic? Heart structure, heart layers, heart walls, valves, chambers, anything in that arena? Did you go home and get comfortable with the epicardium being the same thing as the visceral pericardium? Convince yourself you see how that works? Any questions on that? Sure. I'm just going to draw a real simple schematic diagram. Hopefully that'll make it real clear. Let's say we're going to take a needle and pierce the heart from the outside to the inside. The outermost covering on the heart is a type of pericardium that we call what? Fibrous pericardium. All right, come in one more layer, and that's where we're going to have a serous membrane, and that serous membrane is known as the what? Parietal. Yep. I'm going to make an intentional space between parietal and visceral because in this space right here is what?
Serous fluid.
Serous fluid. And that space actually constitutes what we call the pericardial sac that separates the fibrous and parietal pericardium from the visceral and the heart itself.
Could you say serous pericardium though, because you've got it on number 2 and then parietal layer?
You could. I would probably keep in the back of my mind specifically which layer of the serous membrane it is.
Okay.
Yeah. That visceral pericardium is the innermost of our 2 serous membranes. Visceral pericardium also has an alternate name. What is it? Epicardium. Good. That visceral or epicardium is actually like shrink wrap. It adheres very tightly to the heart muscle itself. If you were to try to remove that visceral pericardium, it'd be like pricking away the actual muscle as well. So it's not a layer that you can actually separate from the rest of the heart. Come in a layer deep from your visceral pericardium. Now we're in what layer?
Myocardium.
Myocardium. Myocardium is that big muscle layer. Okay, and then the innermost of those 5 layers is going to be your endocardium, and that lines the innermost portion of the heart, inside of your atria, inside of your ventricles. So that would be the deepest of those 5 layers. Does that kind of help? Okay. How about other questions on those 5 layers or walls? I'm going to get this thing. I don't have it sync trapped out on both computers, so let me sync it where I can see it on the laptop screen. There we go. In class on Tuesday, I had mentioned to you the NIH website, and they have a pretty nice little animation there. Unfortunately, I can't make it any bigger than this. The link is in D2L in the announcements area, so if you want to go home and play this and look at it where you can actually see it a bit better, use that link in D2L. I thought I would start off today by reviewing Tuesday's blood flow. This animation is actually going to give us a sneak preview of diastole or diastole and systole, or the other name is systole. So let me get all set up here and we'll take a listen. Make sure we got some sound.
Your heart is a muscle that works like a pump to send blood throughout your body. It is divided into right and left sides, separated by a septum. Your heart has 4 chambers, a right atrium and ventricle, and a left atrium and ventricle. Your heart has 4 valves that regulate the flow of blood through the heart, its chambers, and the arteries. The right and left sides of your heart work together to pump blood. The right side of your heart pumps blood from your heart to your lungs through the pulmonary artery. The left side of your heart pumps blood to other parts of your body through the aorta. A pumping cycle begins when blood from your body that is low in oxygen returns through the superior and inferior vena cava to fill your heart's right atrium. When the right atrium is full with blood, it contracts. The tricuspid valve opens, and blood is pumped into the right ventricle of your heart. This is called atrial systole. When the right ventricle is full with blood, the tricuspid valve closes. This prevents blood from flowing back into the right atrium. Full with blood, your heart's right ventricle contracts. The pulmonary valve opens, and blood is pumped into your pulmonary artery and onto your lungs. This is called ventricular systole. The pulmonary valve quickly closes to prevent blood from flowing back into the right ventricle. Oxygen-rich blood returns from the lungs through the pulmonary veins and has filled your heart's left atrium. Your heart's left atrium contracts. The mitral valve opens, and blood is pumped into the left ventricle. This occurs at the same time a new contraction is taking place in your heart's right atrium. When your heart's left ventricle is full with blood, the mitral valve closes. This prevents blood from flowing back into the left atrium. Your heart's left ventricle contracts, and the aortic valve between your left ventricle and aorta opens. The contraction pumps oxygen-rich blood into your aorta and onto the rest of your body. The aortic valve immediately closes to prevent blood from flowing back into the left ventricle. This occurs at the same time a new contraction is taking place in your heart's right ventricle. Meanwhile, your heart's atria has filled with blood, and the cycle continues.
Okay, so our last topic in here on Tuesday was blood flow, and I had left you with an assignment of looking at those lists of structures through which blood passes in your course pack on page 39. How are you doing with the blood flow and your circulation? Let's just kind of go back through that list one more time and start off with the superior vena cava, inferior vena cava, and on the back side here we've got the coronary sinus. Those 3 are veins that carry deoxygenated blood. They return that deoxygenated blood to the right atrium. Alright, so where do we go next?
Right ventricle.
Tricuspid valve and then right ventricle. Good. That tricuspid valve is hanging limply open as the atria contracts and does push blood through that little tricuspid valve. As the right ventricle begins to fill with blood, the pressure rises and then the contraction starts. That contraction pulls down on those papillary muscles and those chordae tendineae. That slams shut your AV valve, including your tricuspid valve. That leaves us with only one place to send blood. Now where do we go?
Pulmonary semilunar.
Pulmonary semilunar valve, good. Now we're in this blue trunk known as a pulmonary artery, and that's taking blood where?
Lungs.
Lungs, good. When we get into the respiratory, we'll talk more specifically about that gas exchange, but we're dropping off carbon dioxide and picking up oxygen. Now we're going to return back to the heart by way of these red veins. We talked in class on Tuesday about how that's kind of bizarre. We normally don't expect to find veins colored red. Normally veins carry deoxygenated blood rather than oxygenated blood. All right, so where do we dump now? Left atrium. Left side of the heart is oxygenated blood. We now take that oxygenated blood coming back from the lungs, from the left atrium, through what valve? Mitral valve or bicuspid valve, either one's good. That valve also hangs limply open during blood filling into the heart. As that blood drains down into this chamber, left ventricle, as the pressure starts to rise, what happens to the mitral valve? Closes. You have one place for blood to go, and that's where? Good. Aortic semilunar valve will now open. Blood will flow through, traveling to your aorta, and as blood passes through, then that aortic semilunar valve slams shut. The closing of those semilunar valves prevents blood from backflowing where? Ventricle. Yeah. These two semilunar valves take blood into the pulmonary trunk and into the aorta, and they prevent blood from draining back down into your left and right ventricle. What do the mitral valve and the bicuspid valve prevent from happening? Good. Blood from backflowing into the atria. So the whole name of the game with those 4 total valves is preventing backflow. All right, once we're in the aorta, we're going to travel out through the body's arteries. Smaller arteries known as what? Arterioles. Finally into the very smallest vessels known as capillaries. Capillaries are the site of gas exchange and nutrient exchange. Finally, those gases and whatnot will be carried into our venous system, starting with the tiniest veins known as what? Venules. Venules join to form veins, and then we'll dump back into one of 3. IVC coming from below the heart, SVC above the heart, and coronary sinus. What is coronary sinus bringing blood from? The heart itself. Good. Cardiac circulation, heart itself.